All right, example 2 says find all the solutions of the polynomial. So letter A says x squared plus 7x plus 10 equals 0. Now, it was all well and good when we were trying to use the zero product property before because it was already factored for us, and it was really easy to do. Now here, you might not even recognize, hey, I got to factor this in order to solve. Some people might try subtracting 10. So if we did that, we'd have, x squared plus 7x equals negative 10. Then they might try to factor out an x, and we get x plus 7 equals negative 10. So we get kind of a mess here. You can't set each of these equal to 10. The only time you're allowed to do that is when it's equal to 0. So instinct is to move that 10 over, but that just creates a mess. So we can't do that here, which is why people, or not people, but factoring was kind of discovered because it actually helps us solve these quadratics here that have an x squared. If it's just a regular x, have fun, just subtract and divide and multiply and everything. But here we do have to factor. So finding all the solutions of the polynomial, you have to factor this first, and the factoring we always do. Remember our 3, we had GCF first, then special patterns, then guess and check. Now you might be getting really good at this, that, oh, there's no GCF, okay? Oh, there's no special pattern because the square root of 10 doesn't work. So we are going to have to jump right into guess and check with this guy. Don't forget to put your equals 0 here. These two binomials only come from this side right here. So don't forget that equals 0 because some people forget to actually solve these. So when we factor, we need x squared here, so this should be x and this should be x. Then I need factors of 10 that add to 7. Those are going to be 2 and 5. You're already thinking that. And then plus and plus. Just to mentally check, x times x is x squared. X times 5 is 5x. This is 2x. That does make 7x. And then 2 times 5 is 10. So we did factor correctly. Now that we have this in factor form, we can use that zero product property to split these up. So we have x plus 2 equals 0 and x plus 5 equals 0. And then to solve here, we would subtract 2 from each side and get negative 2. Here we would do the same thing but get negative 5. So our two answers here are negative 5 and negative 2. Now, it's no surprise, these are both plus plus, so they're going to be opposite signs, so negative 5 and negative 2. So if you can recognize that, you don't have to do this part anymore. Okay? Be my guess to just say, oh yeah, negative 5 comes from this guy and negative 2 comes from this guy. That is A-okay. Now for letter B, it says 3a squared plus a minus 10 equals 0. Again, you're going to have to factor these to solve. So let's go ahead and make sure can we find a GCF? We have 3, 1, and 10. A squared a, and no, GCF isn't going to work. Special pattern, square root of 3, nope, that's not going to work. So let's go right to guess and check then again. So we set it up like so, not forgetting that equals 0. And to get the 3a squared, we're going to need a 3a, and we're going to need an a. So now for 10, we can do 1 and 10 or 2 and 5. Let's do 2 and 5. Let's do 2 here and 5 here. And we need alternating signs that make a positive. So this is the bigger one. So that's here. So now let's mentally guess and check, or excuse me, FOIL to see if we can check it to work here. So 3a times a is 3a squared. 3a times 5 is 15a. Minus 2a, does that give us the 1a that we need? No. So those are not going to work there. We might be able to switch the 2 and the 5. So let's maybe try that. So I have 2 here, so 5 here, 2 here. And then I need my bigger thing. Now this is going to be 6a, so that will be bigger, so that needs to be positive. And this, I think, needs to be negative. So 3a times a is 3a squared. 3a times 2 is 6a minus 5a. That does give me the a that I need. And then negative 5 times positive 2 gives me the negative 10 that I need. So we did check out here. So that means we factored properly. Now looking at this guy, I know that this guy is going to give me a as being negative 2. So I know that that is one of my answers. If you don't see that, we would just say a plus 2 equals 0. How do you solve? Well, subtract 2, and you get a is negative 2. So that you should kind of be picking up on. Now these, since I have something with my a, I didn't over here, I have a coefficient with my a here. Well, you're going to have to add the 5 over and then divide by 3. So here a is going to be 5 over 3. So your last thing over your first, and of course it's still the opposite sign. We had a negative here, so our answer is going to be positive. Those are a little harder to see, so if you need to write out 3a minus 5 and solve it, then please do. We'd add 5 to both sides. We get 3a equals 5. We divide by 3 on each side, and we get 5/3, just like I said we would get 5/3 down here. So if you figure these out too and say, okay, it's going to be positive 5/3, then you don't need to show any of this work anymore. If you'd like to show the work, be my guest. So here are our answers. We have a equals -2, so a equals -2 first, and then 5/3 next, to put them in order. Okay, just double checking. Each of these I only got 2 solutions for, which if you look at both of them, our degree is 2 in each of them, so I should be getting 2 answers for each product. Okay, let's go ahead and I'll wait till the next video to do the last example for you, and then you guys are going to have a couple problems to try yourself. So I certainly hope you join me for the next video. Thank you.